All right, today we're jumping into a manufacturing process that honestly sounds like it's straight out of science fiction. We're going to talk about how to join solid pieces of metal together, creating a bond that's just as strong as the original metal, but, and this is the crazy part, without ever actually melting it. Let's get into it. So when you picture welding, what comes to mind? Probably sparks flying everywhere, that super intense light, and molten glowing metal, right? Well, what if I told you that you can get an incredibly strong weld without any of that? It sounds kind of impossible, but yeah, you totally can. The secret is a process called friction welding. Now, the key phrase here is solid state. Instead of melting metal down to a liquid, it uses the simple, powerful force of friction to generate a ton of heat. This makes the metals soft and plastic-like, just enough for them to fuse together permanently. And the wildest part? The final bond isn't just strong, it's as strong as the original parent metal itself. Okay, so to really get our heads around this, here's how we're going to break it down. First, we'll look at how you can possibly weld without melting. Then we'll dive into the science behind it. After that, we'll check out the three main types of friction welding, weigh the pros and cons, and finally, see where this amazing tech is already being used out in the real world. So let's get right into the big question. How on earth does this actually work? Well, the core idea is actually something you already understand. The whole secret to welding without melting comes down to the pure science of friction. You've definitely experienced the basic principle. Think about it. On a cold day, what do? You rub your hands together, and that friction creates warmth. Well, friction welding just takes that same exact idea and cranks the dial way, way up. You see, if you could zoom way in on any metal surface, even one that looks perfectly smooth, you'd find it's covered in all these microscopic peaks and valleys. So when you smash two surfaces together under pressure and start moving them, those tiny little bumps crash and grind against each other. This creates an absolutely immense amount of friction, and all that friction generates a massive amount of heat right where you need it, at the joint. The whole thing really happens in 4 quick stages. First, you start moving one piece of metal relative to the other. That motion, as we just saw, generates some serious heat from friction. Now, this heat doesn't melt the metal into a liquid. Instead, it just brings it to a point where it becomes viscous, kind of like a super thick plastic. At this point, the materials can actually mix together. Then, you stop the motion, the metals cool down, and bam, they're fused into one solid piece. Okay, so now that we've got the basic principle down, you can see how engineers have cooked up a few clever ways to create that all-important motion. Let's look at the 3 main types. They all use the same core idea, but they just apply it in slightly different ways. First up is rotary friction welding. This is kind of the classic method. Just imagine clamping one piece of metal down so it can't move. Then you put the other piece in a spindle, almost like a lathe. You spin that piece at an incredibly high speed, and then just force the 2 ends together. The friction does all the rest. But what if your parts aren't round? Well, you can't exactly spin them, right? So for that, engineers developed linear friction welding. Here, one piece is held still, while the other one is oscillated. Basically, it's moved back and forth at a super high frequency. So it's less of a spin and more of an intense, powerful vibration that generates all the heat you need for the weld. And finally, there's this really clever one called friction stir welding. This one's a little different. Instead of rubbing the parts against each other, you use a special rotating tool. This tool, which doesn't get consumed in the process, is pushed down into the joint between 2 stationary pieces. It spins, creates heat, and makes the metal viscous. Then it travels along the seam, literally stirring the 2 pieces of metal together like a high-tech kitchen mixer. This is absolutely perfect for joining big, flat sheets of metal, like on an airplane wing, without warping them. Now, of course, no technology is a magic bullet for every single situation. Friction welding has some absolutely incredible strengths, but it also has some pretty specific limitations. So let's take a fair look at the trade-offs here. On the plus side, this is a total game changer. You can weld totally different metals together, like aluminum to copper, which is notoriously difficult to do with traditional methods. You don't need any filler metal or flux, and a huge one, there are no fumes or toxic gases, so it's a much cleaner process. The welds are top-notch quality, and the whole thing is fast and super easy to automate. But on the flip side, the machinery has a pretty high setup cost, and you need some really heavy-duty clamps. With stir welding, you're often left with a little exit hole where the tool pulls out. Plus, the process requires a massive amount of force pushing the parts together. So, keeping those trade-offs in mind, why does this all matter? I mean, where is this awesome technology actually being used? Well, it turns out it's in a lot more places than you'd probably think. From the planes in the sky, to the car you drive, to the power lines in your neighborhood. In really high-stakes industries like aerospace and automotive, it's used for critical parts like piping, shafts, and drive lines. The kinds of parts where failure is just not an option. It's also the go-to method in the electrical industry for joining copper and aluminum components. In fact, it's become so reliable and efficient that it's actually starting to replace more expensive traditional processes like casting and forging. When you get right down to it, its value comes from this. In our world of mass production, efficiency is king. Friction welding isn't just strong and clean, it is incredibly fast. The ability to churn out a perfect, high-quality weld in a really short amount of time is just a massive advantage for any manufacturer. So we'll leave you with this thought. Here we have a welding technology that is stronger, faster, and cleaner than a lot of the old-school methods. It doesn't create toxic fumes, it doesn't need extra materials, and it can join metals that were once almost impossible to weld together. So as we all look for more sustainable and efficient ways to build things, you have to wonder, what new doors will friction welding open up next? It's already shaping our world in ways you probably never see, and its potential is just getting started. Thanks for watching.